connected.
Yeah. Good morning, guys. With the Baku Times, who is attended from the Baku Times, and good evening from the different time zone. Today we are starting our next webinar. Hello, everyone. Thank you for joining us, and welcome to our today's webinar. Today, my name is Rasim. I'm community leader at GoUp. Today, we are going to start the amazing webinar with the amazing speaker. His name is Elmar Abbasov. Approximately, we have 1 hour, 90 minutes for this webinar. And Elmar will talk about his topic, and we will give to them the questions. And just wait. Okay, let me talk about give brief information about the today agenda. Now we have the 10 minutes kickoff. We have the introduction. After introduction, I will give the control to our speaker. He will represent his presentation. We will listen him. And after that, we will take 5 minutes break, about 5 minutes, and we will turn to our Q&A part. After that, we will finish today webinar. And before starting, let me give a brief information about myself and about our GoUp community. As I said, my name is Rasim Abdullayev. I'm community leader at GoUp, and at the same time, I am instructor at Azerbaijan State Oil Industry University. Let me give brief information about the GoUp. GoUp is an open source project where we are building the egoist, collaborative, fun community culture with follow the structured and indexed data. There are our main principles of this community, and we are making the next generation community at GoUp. So let me turn to our next. Okay, today I want to introduce the co-host. Burun Hajiev is our co-host today. He is from the Expert Tech. He's Expert Tech also providing the monthly meeting by the ATL group to bring the IT mind together for people. And welcome Burgun Meryem. If you have some speech or welcome, you may. Okay.
Go ahead. Thank you.
Okay. Let me give our social accounts where you can reach us, and you want to use this kind of the social accounts to be part of our community. The Slack group in the first line, you may use this Slack group for the joining to our community. Yeah. Then our today sponsor All My Taxes, and we are grateful to them for support us, and thank you for them. And let me give a brief information about our code of conduct. It's our little rules, which is I'd like to highlight as a code of conduct. We will talk here the work language is English. We are here to collaborate the equals, to learn benefits, to contribute. We are equal to despite our rules and personal accomplishment. And I would like to highlight about the no marketing, no selling, and competing issue in this webinar. Now time to take photo. Let me stop my sharing. And okay, please don't be shy. Open your camera for take the moment. One more. One more. Okay, good. Thank you. Thank you. Now I would like to give the word to our speaker. As I said, he's Elmar Abbasov. Today, amazing topic. He will talk about the robotics engineering, autonomous driving, car systems, and etc. Now, Elmar, please take control, and you may open this presentation, share your desk, and let's go ahead, start to our webinar. Thank you for all. Thank you, Elmar. Let's start, Elmar.
Yes, thank you. Before I start sharing my screen, I would like to let everyone know that I'm very excited to be here. I didn't really expect that this many people would be joining to listen me just speak about something I love, but I appreciate it. It's valuable for me, and I hope that I can provide some value also. So, I will start by talking about myself for a little bit. Basically, I've been a professional software engineer for around 4 years now, in context of robotics. Before that, I studied at the University of Tartu, and before that, Azerbaijan Technical University. The reason why I went with robotics as a field that I want to follow was because it's just a field that excites me the most about programming, and I will try to do the same for you today. Basically, my excitement about robotics wasn't born overnight. I tried to do some other programming fields also. I did game development at some point. I did web development at some point, but in the end it was robotics. And robotics to me is the most exciting field that you can be in the software engineering community, because you get to work with very interesting toys, and you get to be on the bleeding edge of the technology. Basically, with other kinds of software and hardware, etc., you don't really have to be on the bleeding edge of it to have a product. You can be using, I know, 5-year-old tools and still achieve something. But with robotics, you always have to be on the bleeding edge. So if you're excited about technology like I am, if you're excited about working with these new technologies, I would urge you to look into robotics. Basically, this timeline here is what I've been up to. I can two of these points. One is this AsRoboHack robotics competition and this Robotics 16 robotics competition. One of them was in Azerbaijan, and the other one was in Estonia. I would like to show you some of my first robots. The one on the left was basically a very crude hand robot, kind of. Basically, it was meant to be an remote-controlled industrial hand, and this was made for AsRoboHack competition back in Azerbaijan, and I won the first place with it. And that was something that I used for getting into University of Tartu, because this is such a field that however much hackathons you attend, networking you manage to do some side projects, those are all very important and will be useful for you. For me, how it was useful was that I actually managed to get a scholarship to study in Estonia. and actually studied for free, and even got my living expenses sorted out. So I managed to move here and study in this great university. And at some point, I was a teacher at the university, but what I was teaching was mainly Internet of Things rather than robotics. But if you ask me, those are kind of similar neighboring fields, because in both cases you are working with hardware. In one case, it doesn't have any wheels or doesn't do any manual labor of sorts, but on the other one, it does. This the video on the right is about second robot I built. This one was for the competition of Robotics, where we were working on a football playing robot. And if you look into this, okay, I really love how this shot happened. This robot is fully autonomous, by the way. It aims and shoots by itself. It might look some complicated, but it wasn't really that complicated. This was written in Python, and it was using some mini PCs in order to mini PCs and cameras in order to find the ball in the field and find the goal. But these kinds of projects also are not by themselves enough to get into actual robotics. They are really good starting points. They're good as foundation for you to build your experience from and move towards more complicated problems to solve. Introduction to robotics. By the way, I will keep talking, but if you have any questions at any time, I think you can still ask it. I'm not sure. Maybe Rasim Malim can say more, but there is a Q&A session in the end. But if there is some burning questions, feel free to ask them. If you want to talk about robotics, I would. You can't talk about robotics without talking about these three rules, and I will tell you about their significance in a bit. Basically, these are the three laws of robotics. First rule is that a robot may not injure a human being or through inaction allow a human being to come to harm. A robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. A robot may protect its own existence as long as such protection does not conflict with the first or second laws. Now, this is not some guideline from government or some actual laws regarding robotics. These were the words from I, Robot from Isaac Asimov in 1942. What's interesting to me about this quote and this was, it keeps reminding me why I chose to be in this field, because if you look at the years, 1942 was the time when Isaac Asimov actually came up with the word robotics, and this was a part of science fiction. And it took a whole more than a decade of time for this to actually come to fruition and first actual robots to be used in industry. And I like to think about that in a way that because this was something that people dreamed of before being actually capable of doing, and that is one of the things that draws me towards this field. By the way, it's a good book if you want to give a read. So I know that a lot of people here are students who are already interested in robotics, maybe studying it. So there are some technical questions that I would like to answer, whether it be about robotics or the software we use. Basically, mainly, I would say that people are confused about robotics, mainly who don't know what it involves. Robotics engineering is not just one kind of a job. It's not just electronics, it's not just mechanics, and it's not just software. It's a mixture of these three, and there's even more involved, but like I'm generally simplifying here. What I will be talking about will be mainly focused on the software part of this, because I am dealing with software part. Yes, the question that I get asked almost every day, which is which programming languages do we use? The main two languages we use would be Python and C++, and they both offer different sets of pros and cons that enable us to use them and be efficient with it. C++ is a very high performance language, if of course, if written properly and compiled with correct settings, etc. But what's an issue with it is that you cannot have faster development with it, because any robotics project can get you might need to come up with something real quick and have a minimum viable product, for example. And in those cases, it is better to write those things with Python. And with Python, because this you can prototype so quickly, in some cases, it's more useful to use that. But in case you would be interested in getting a work in robotics, I believe that having experience with both of these languages would be preferable, but even if you have in one, and it should be good enough. Another reason why these languages are chosen most of the time would be that because both are popular languages with huge communities around them, and both have first-class ROS support. Now, ROS might be an alien word in this context. I would like to, oh, you can't see the top of it. Okay, so basically this is talking about what the life was in robotics before ROS came. Now, this might be familiar to those of you who have some experience in engineering backgrounds, software engineering backgrounds, that you want your code to be as reusable as possible. You want to abstain from reinventing the wheel whenever possible. But with robotics, it was an issue because a lot of the software parts were not reusable, and you would have to start from scratch to achieve basic functionalities that you shouldn't need to. And that's where this open source project came in the name of ROS that solved these issues. What it is mostly about is it is set of libraries and tools that enable you to work in a more standardized way. I think I can show you a little demo about, not exactly ROS, but this is basically going to be another open source tool that's highly connected with ROS. And here, what you get to see is basically some sample data from real time of what a robot will be seeing in it when it's working. Here, if you want more information about this, basically this screen on the left is LiDAR data. This is the 360-degree laser sensor that gets to see the world around the car or a robot in 3D. this is some camera data. This data is from a car, and there are quite a bit of debugging information also. It might look a little bit of intimidating at first, or you might not get what is going on. It's just I like viewing these kinds of data when I need to debug something, because in some scenarios it is not easy to figure out what you are looking for and what's going wrong with the vehicle, or what the vehicle is thinking. So there will be a lot of tools like this if you are working with projects that will help you out. And this is a part of tool sets that people usually use with ROS. Let me get back. Okay. Oh, by the way, I would like to take a moment and give some information to university members that are in here, because Rasim Malim told me that there will be people who are staffs from universities and who are actually dealing with the curriculums. And I would like to mention that if there is one thing you would take away from this talk today, it would be that ROS works great as a part of a university curriculum. That's how I started with becoming a robotics engineer. I had a course in the University of ROS, and it greatly improved my chance of understanding the field and getting into the field. So yeah, that's Rasman, you mentioned that you would like to say a few words about that, or
about the robotics operating system, you mean?
Yes, a part of a university curriculum.
Yeah, it's good that to use at the university is kind of the operating system or some simulator for add to the curriculum for the students, because the robots, part of the robots or the bring to the university, it's expensive and take some cost. But for with simulations and for how to say really curriculum systems, it will be good that to represent to students for the learning this field, for testing, for the analyzing, for implementing, or etc. But I don't know. I'm not sure that in our universities there is a kind of the simulator or not. But maybe we will discuss after the meeting, and we will take some brief info to represent to our teachers from the universities.
Yeah,
if you suggest great. some the links or platforms for kind of the simulators, you may share with us. I will add to our chat below for the sharing with the participant.
Yeah. We can look into that also with ROS. As you mentioned, it can be a very useful thing, and basically, as a part of a curriculum, you can make it easy or difficult, as in, like, basically you don't have to be involved more than you want your students to be or your university to be, because there are parts of it, like you mentioned, works with a simulator. So you develop some software, test it in simulator, and that can be a part of coursework. Or the same code you get to deploy on an actual robot and test it that way. It can be an invaluable tool in that sense.
Elmar,
yes.
If you don't mind, we have the question in our chat.
Okay.
Rufat, thank you for question. He has written that, do you use robot operating system or ROS2 on actual product, something actual product or something development in house? It's like for you.
Yes, good question. Yes, I use ROS for almost like 5 years now, and 4 years of it professionally. I've in almost every place I've worked before, we have been using ROS. I haven't used much of ROS version 2. I know that it is more recent, but it's still basically these tools are so comprehensive that they go through years of development and testing before they can actually be used in the industry. And ROS 2 is just not there yet, but it is a promising new update that will come to ROS. But so far, the most I've worked with ROS. And yeah, I would like to mention that the reason why I mentioned ROS is that because almost all companies dealing with autonomous driving do use some version of I'm sorry, some version of ROS. Maybe not exactly, but maybe they use it with some other middleware. And I will mention the other middlewares used also. But the importance of using a platform like this comes with not wanting to reinvent the wheel. And of course, if you are in a small startup with, let's say, 10 people, you would want to have the best foundation you can. And ROS basically enables you that. With the help of ROS, for example, the University of Tartu recently, this 10 people team, in a few months, they managed to get a car running autonomously in a small city run. You cannot do that unless you rely on good open source projects like ROS and some others that I'll be mentioning. So in the university and in the industry, both do work with ROS. And I am hopeful about the future for ROS too, but not yet. Yeah, now that we talked about ROS, ROS can give you tools for overall robotics, but a part of this is also autonomous driving. Oh, there is this interesting question here that do you know, what would be your guess about which company produces and sells the most robots in the world? The answer to this question, according to Andrej Karpathy, the director of AI at Tesla, was that it's Tesla. And I totally agree with him in this, that although it doesn't feel like this would be a right information, but basically cars that do autonomous driving are basically robots on wheels. And that's why the most popular robots today are autonomous cars. And that's how this relationship between robots and autonomous driving cars exists. Yeah, this one is something that I have to talk about every time I'm mentioning anything related to autonomous driving. It is how governments see the levels of automation. This is, I don't really agree with this chart that much because there are so many blurred lines in between different levels of autonomy here that it is not really easy to make these distinct levels possible. There can be some occasions where, let's say, this level 4 is actually more difficult. It is actually easier to achieve than level 3. It's all about, comes down to not being able to describe these terms and the capability of the car without actually going into details, which is something that can be an issue with autonomous cars. But I believe that we will, in the future, either have a better explanation for the levels of autonomy, or just give up and actually go with this until we get level 5, what they call full automation. Now, in order to go there, achieve that autonomy, there's also a lot of other middlewares that you would be using in order to get there. These 3 platforms are most popular autonomous driving middleware software, and all of them are compatible with ROS on some level. Basically, if ROS has given you the most basic tools that you would need for communication and let's say distribution of computing with your robots. Now, these autonomous driving middlewares give you the next step and get you closer to having a better architecture for your driving. This is, for example, a simple diagram for what kind of parts does the system have. This one is from Outverge, this one, and this is the one I have used the most. But there are others, but with also similar divisions. This, when you look at this screen, you can look at basically these elements are all elements that you would need to have in your autonomous driving car. Some companies disagree with one point or a few. For example, I know that Tesla isn't very fond of LiDARs. It will still be a time until we know if Tesla's bet on that is correct or not. But overall, almost every autonomous car has cameras, IMUs, which stands for inertial measuring units, which are used for basically seeing acceleration and rotation. And you can have GPS connection, and there's also actually way more sensors that are used in these cars. But mainly, what I'm talking about would be what I work with, and I work with the computing part of the software stack. Let's say this diagram might not look like this. It is very helpful, but it is because in every step of the way, unless you know all of the steps that your car should be taking, if you are learning, let's say if you are recently started learning about these systems, if you want to get into this now, you should you should look into one of these and pick yourself where you would like to start. For me, I've worked with many different parts of it so far, and I like perception as a very fun one, because perception includes prediction, detection, and localization. And prediction can be basically predicting where other cars are going to be in the future. With detection, you can detect that there are cars or other people on the road or bikes, etc. And localization is an interesting problem that still there is some struggle with solving that, even in the highest grossing companies, that it is localization is about it's about robot finding itself in the world and knowing where its own location is. And once you have the perception, once you know what's around you and what's your state. You basically make a decision and plan your mission, whatever your task, your current task is, and you work towards that. Actuation part is rather a solved problem. A lot of cars you will be working with will have some part of actuation working on to actually actuate your car. And if you ask about programming languages that would be used here, I would say that for most of these computing section, you would need to use C++ because of the high performance requirements. But for utilities and some system tools, and sometimes even in computing, using some Python for having not high performance intensive code running is okay.
Elmar,
Yes.
we have two questions, but
Okay.
I suggest to stay in this slide, because this is a general conceptual model you have represented to us, but I have my own question by detail. But before turn to my questions, let's read from the chat below. The Nurlana asking that how similar to humans should the robots become?
How similar? Well, actually, they don't have to become similar. This is more of a philosophical question than a technical question. Well, depends on what you want the robot to do. If it is going to have to do human tasks, then of course it would be better suited if it had a human form. If you are asking about level of intelligence-wise, how similar, then I hope robots are smarter than humans in the future, because otherwise there wouldn't be much of a point.
You know, Elmar, the topic is a very actual topic, and if the looking for from the from the directly go to this topic, robotics is becoming like the black books for us. We are that's why the question will be, and the people want to understand what's happening inside of the black box. Now you are representing to us the general overview of your with blocks, but the inside of that blocks, what we have. So we have the one question from the Humay. Humay, you said that could excuse me. Yes, you have question. Please, Humay, represent your question.
Hi, my name is Mai. I am a student. Thank you for such interesting presentation. I ask this question: which kind of algorithms are important to teach to robots and cars for self-drive?
Good question, Elmar. As you see, thank you, Humay. As you see from the picture, that we have the couple of the blocks and the camera, IMU, GPS. I mean, all of these blocks is working with some algorithms, and then the computing part, it's need to separate. I mean, it means the integration with that algorithms with your computing part. So question is very in time question, and please, Elmar, by detail, what kind of the algorithms you are using with teaching your autonomous car or robots?
Okay, if you want to actually know, we can go down to actual algorithms. Basically, the entry answer to this would be that basically every block here uses different kinds of algorithms, most of the time multiple of them. But basically, every once in a while, there is a scientific breakthrough in one field, and there is this like new algorithm that works great for some certain situation, and it is used for the next few years. Some of these algorithms are AI-based algorithms. Some of them are not AI, just run-of-the-mill scientific algorithms or math related. I'm not sure how to come up with ways to explain a few algorithms in this scenario. Okay, I'll show you one that I actually mentioned in here. For example, this one on the left, right? This is a screenshot from this neural network based image detection AI neural network. It is a good software that in real time detects objects in an image, be it humans or cars, bikes, traffic lights, etc. And it is highly performance intensive, as in it works quite fast, and you can have it working on real time in the machine, which is like an important part of the requirement for if you want to use this algorithm on your robot, because you can have a very good algorithm that does, I know, 99% accuracy, but if you cannot run it on a normal computer PC, normal GPU or CPU that you would find at home, or I know, let's go a bit more expensive, it will still not work for you. And this, for example, this YOLO thing, which is for detecting objects and humans from image, this would go for the detection part of perception. Of course, you can use it solely as all of your detection, but you can use it for detection from your camera images. There will be other detection algorithms you will use, but this would be a part of it. And it goes the same with other parts also, about like what you want to, what kinds of algorithms you use. I just remember that I used to think that when I just started with this, and we were basically testing different algorithms to put in every box here to get a working system, it feels like more like playing with Legos, finding some algorithms that's fitting your requirements, or writing that said algorithm. And in our case, it was basically half taking it from open source community and half developing it ourselves. And I'm not sure if I managed to answer that question.
No. Thank you very much.
Yeah, thank you, Humay.
Thank
we
you.
have another question in our chat. Let's discuss this question also and then continue. The Nurlana again is writing that, as we know, they should be able to perform tasks people are able to do. So question was, how many of the human abilities should they have?
How many of the human abilities?
The Nirvana boss question is are that about the human brain. The Nirvana thinking that the robots should be nearly the human brains. That's why the questions kind of the nearly questioned about the what the abilities, how many the human abilities should they have.
Yeah, that's actually, like, I have this meme that's kind of related to this in the next slide here, which is when you talk about AI in robotics, there can be instances where it is just actually a bunch of if-else conditionals that they claim to be AI, which is kind of a misconception, but at the same time, you can't do anything about it because it can also be considered AI. And it also, with the question, it also comes down to what kind of intelligence are you looking for in this machine? If you are looking for in a narrow, let's say, base that it's supposed to do this one simple task, and then it needs all the senses and abilities that a person would need to do that job. But if you are talking about having some kind of a general AI that would be able to think like a human or do things like a human, it is probably not going to happen any soon, because as we know with AI, for example, this AI I just talked about, it is good for extracting objects from images, right? And a lot of AIs are quite good for simple tasks. It's not a simple task, but like it's a simply explainable task that you can, you have a given set of inputs that are quite correlated to the result you are trying to get. You can label the data, you can teach the AI to do that. And that's kind of simple for an AI to deal with. But if you were to say that, oh yeah, I will give you this camera, LiDAR, IMU, and GPS to you, and just do whatever you want with this whole computing thing, and just give me a steering value and pedal value so that my car would go. AI today cannot do that. And maybe someday it will be possible, but we will need quite a few breakthroughs in AI to be able to get there. I'm not sure if that's going to happen anytime soon. Maybe it will. I know that some companies are getting closer there, but the main issue with using a lot of AI in the autonomous vehicles is that it is easy to get to 90% safety with this kind of AI that will do the driving for you. Then it gets 10 times more difficult to get to 95%. Then it gets 10 times more difficult than that to get to 98%. It is just at some point it comes to humans and governments to decide when is that enough that we will be able to trust these systems, that we will trust our lives with it. And I believe if you ask for my opinion on that, it would be as soon as the casualties are lower with AI and software-based driving than human driving, which is in some cases already has reached. I know that this might sound as incorrect because we hear about casualties with self-driving cars often, but the reason we hear about them is that they're a rarity and they are more inclined to talk about it because it is something that shouldn't happen. But if it happens, and it happens still way less than human errors, human-based casualties, then it should be allowed. But nowadays, every country has different rules and legislations again about that. Estonia, where I'm living and working right now, is actually quite good with that. They every year, with help from startups and other companies, there are new additions to the road rules, and most of that is about actually self-driving vehicles. And I am happy to see that that things are moving in a correct direction.
And if you want to continue, let's continue. After that, we have the question from the Rufat Bayramov. Okay, maybe we have the one slide for the finish. Yeah, Elmar. After that, let's go to Q&A part, because as I see that Ravi also want to ask question. Okay, let's talk about this. Sorry, let's talk about this slide for viewing, and after that we will turn to Q&A part. Yeah, and we will ask Rufat Bayramov question too.
Yes. So yeah, in the end, like you might have the question of, if you are interested in this field, how can you get to it? As far as I know, if you have, I know more than half of the points that I've mentioned here, I would be interested in like recommending you to, let's say, where I'm working at, and I'm sure that there would be companies that would be interested in hiring you. You would need to learn, of course, some programming languages, and of course, this is about software engineering point of view. We can, if you have questions about some other field, feel free to ask that also. But yeah, you need to experience in Linux is good because most of the robots usually are based on Linux system because yeah, nobody wants their car to ask for updates in the middle of driving. And playing with hardware related projects is a great way to learn new stuff and test actually the stuff that you have learned. There are microcontroller based computers like Arduinos and Raspberry Pis that are very good for that. I've played around with both at different times when I was doing freelance projects. And experience with ROS. If you look up on the internet, ROS has its own tutorials, and there are a lot of platforms recently that are teaching about how to work with ROS. And yeah, going to hackathons and robotics competitions. I'm not sure if your university or where you are will have that kinds of events, but there are even like I know of international events that grant scholarships to go and attend, and you can definitely find some interesting events. Or I mean, nowadays everything is happening online anyways. And a degree, I wrote there depends because it's not really a necessity. For example, where I am right now, but of course, if you have a related degree, it will benefit you way more. Basically, yeah, this would be my points, and we have been way over time, haven't we? Rasim Mellim.
Yeah, thank you. Thank you, Elmar. Now we have from the rules, we have to turn to the 5 minutes break, but we can skip this part. Elmar, please share your desk and turn to the Q&A part.
Okay.
We have a question in chat, and maybe someone will directly ask to you. Okay, let's share this one. Okay, good. The question is that coming from Rufat Bayramov, what's a percentage of software you use that's open source vs custom development?
That's a good question. In my case, it differs based on like how big your company is, how big your team is, because if it's a big team and you have bigger resources, of course, for some things you would prefer more custom development. But in any case, if you are using ROS and outerware and middleware like that to help you along, you will already be using at least half of your software will be open source. In my case, I love to use open source as much as possible because it's robotics engineers' bread and butter, and there are a lot of projects that are very well maintained by others, by universities and by some other robotics companies. It's a good way to actually also network to look into that software, because if you are updating one part of your software, one part of your pipeline, one part of your stack, and some other gets old and doesn't work anymore, it can lead to disasters. But if you use a lot of open source software as much as you can, and they are well maintained and you are helping to maintain them, then you will have definitely better results and easier time. So me personally, I try to use as much as open source possible, and at least half of your software will be open source development.
Okay, thank you. Before turn to question in chat, as I see,
Oh,
Ravi has question. Ravi, please. Ravi.
Yeah, I'm here. Hi everyone, my name is Ravi Hamidov. I am a student at State and Oil Industry University. And my question is, what is the difference between automatic and autonomous?
Actually, I haven't thought about that. Automatic, I guess, is something that happens without manual work, but like in case of autonomous, it can be an autonomous robot can be doing manual work, which would not make it automatic. And at the same time, I don't think automatic driving car sounds like a plausible thing. But overall, yeah, autonomous means that it does something by itself. I mean, it basically with autonomous, it makes a decision to what to do by itself rather than doing something, just doing something by itself when you want it. That's how I understand those terms, at least.
And my second question is, what are the top companies actively involved in the robotics industry?
Good question. Elmar told about Tesla and a couple of other, but it will be better to hear the companies which in the top.
Yeah, there are a lot of companies, and also what you would consider top also depends on your point of view. Is it the funding that the company gets? Is it actually how much people are talking about them? People talk a lot about Boston Dynamics, for example. They do some impressive stuff with their robots, and nowadays. And if you are talking about financially being the biggest, Amazon Zoox platform, which is which is about self-driving buses, has gotten a lot of financial support, and they are working on getting an awesome system out. Or Tesla itself, yeah, Tesla is a very rich company, and selling a lot of robots.
Thank you.
Thanks. Thanks very much.
We have do you have question, Ravi?
No, enough.
Okay. We have another question from the.
I see at least 5
Farah.
questions.
What?
I see at least like 5 questions.
The Ikara is written that when we drive, we use our eyes to decide where to go. But now it's car doing this. What's the main technique for detecting lane lines in roads? Good question.
Yes. That is an awesome question. Basically, yeah, I can go back to this to give more visual representation. If you look at this image on the left, this is basically what robot sees in a 3D sense. I'm not sure, like I have been looking at screens like this a lot, so maybe it is actually not an understandable thing that, but I'm seeing it. If you can tell that, like, this is the car that's using the sensors. There was another car going by, and these are the sides of the road. Here are some trees going on. It's basically like looking at the matrix of the world around you. And of course, there are cameras also, and there are other sensors that help the car see. Basically, what sensors are used at one point in time depends on the conditions. For example, if this If there's, let's say, night and dark, you will rely less on cameras and you will rely more on, let's say, radar and LiDAR and ultrasound. Or if there's during the day, you might rely a bit more on cameras. If it's raining, you cannot rely much on cameras. So for cars, it changes over time what how you see objects, but there's basically the sensor data it gets and the decisions it makes with it, like the detection and prediction. Because I mentioned some part about the detection with algorithms like these ones. This one on the left is about detecting objects from a camera image, and this one's about detecting cars from point cloud data, which is like one you see here. It is able to detect cars by their shapes that's seen in the 3D data. And of course, there are companies who are taking different approaches, but it's usually some combination of cameras and LiDARs and radars and ultrasonics, and also GPS.
Elmar,
Yes.
the question also attract me that for lane lines is okay. You showed that you are using some methods to detect and collect. But how about the AI blind spots, which is the behind of the lane line? How you are teaching the car behind of the lane line, the object in behind of the lane line? I mean, some object. The car cannot see the behind of some objects. How you are teaching? Which method is using for this one?
Well, you try to minimize the blind spots as much as possible in the design phase of the vehicle. You try to have it so that, let's say, you put cameras on all sides. You make sure that you have minimal blind zones in the camera. And you, for example, in this image, we can tell that this is only showing one LiDAR because, you know, it's coming from one source, but usually cars use multiple sensors. They would have four, for example, one on each corner, and that helps with minimizing it. And there are nowadays new kinds of sensors that are more about detecting things around the vehicle itself to eliminate blind zones, and they are used more often nowadays. So yeah, there are different ways, but for most of elimination of blind zones, it has to be decided on the design level to get a better result.
By the way, are there some database where they collected some environmental data for the changing the information between your autonomous car? I mean, car is driving by themselves, and to collect information from it's really, you said that it's collecting information from the sensors, from the cameras, but do we have some database from the environment where it is sharing information with us or the autonomous car to decision making, for helping to decision making?
Yes, that is, it's not implemented yet, but it is a thing called V2X. It's vehicle to everything platform, where your vehicle will be communicating with other vehicles. It will be communicating with the road infrastructure, like, you know, smart traffic lights and some other devices. But from what I know, that there are a lot of tests are happening around this, but there hasn't been any actual implementation. But I am excited to see what kind of possibilities can come up from this. It would be really useful. Actually, if like one of the previous seminars I gave, it was about how if we were to decide to make roads smarter, we wouldn't really need expensive vehicles to have self-driving. If roads were smarter and would let you know about all the conditions that you would need. But yeah, that's not happening nowadays, but there are limited tests happening. So I'm excited about seeing how that turns out.
Great, thank you. We have another question in chat below. Nurlana is asking, what do you think are the biggest challenges facing the robotics industry?
Oh, yeah. The biggest challenges facing the robotics industry. Well, it's nowadays, I guess, not finding enough people who are not afraid of the industry and are willing to come in. Because, you hear people saying robotics engineering, and that can be kind of intimidating, and it actually does intimidate some people. When you put it like just, it's just software engineering for devices, or software engineering for software engineering for things that you can see and touch, that would make better sense, but it doesn't sound as cool. But yeah, I would say that because I live in a place where startup culture is how would you say, ripe, and there are a lot of startups coming up, be it in autonomous driving, because like it's a very small country, but there are like at least 5 companies dealing with robots, and all of them are looking for robotics engineers, but it's not easy to find them right now. You have to and I know that that's the case with everywhere, not everywhere probably, but in most places also. So I guess that's the biggest challenge to me, but I wouldn't want to talk for other people.
Thank you. Raza Hussainov is asking that what books would you recommend for us for inspiration to propose robotics?
Definitely things from Isaac Asimov, because those books have been written before robots were a concept, and also he himself wasn't a robotics engineer or anything. He actually managed to predict these kinds of developments, and maybe it was his predictions that led to actually robotics. Other than that, I mean, I mostly read technical books. I wouldn't call them for inspiration. Oh, there is this book I read recently, just called Ready Player One. It's more about AI and the world of how the world will turn out eventually. But it's an interesting thing to be excited about, bleeding edge of technology overall. I wrote the name in the chat.
Elmar, as you see, the topic very actual, and the people want to, how to say, they earn some mentors. And I mean, for a future, you can a mentor for the students who is in the study in this field, because books, some platforms, some the simulators, which coming from, if will in the future will come from your side, it will be better for the audience.
Yeah, I would like to do that. I would need some time to deal with that, but yeah, definitely can be done. Oh God, I'm so far behind with the questions.
Rufat is active now. He's asking next question: how is the job market for robotics in Europe and US? And he said that I have heard that robotics engineers are paid not enough since they are doing it for passion. Yeah. From your perspective, you are the robotics engineer. You may clearly explain to them that how earn money, how to find job.
Yeah, I earn quite a decent salary. I can say that for myself. And about doing it for passion, Well, of course, like it depends on your situation. You might be doing it for a startup which hasn't gotten any investment yet or something, which in which case maybe you will not get any money. But it is, an entrepreneurship or risk sometimes worth taking. And it might be true in a sense that it's difficult to have robotics startups because robots are hardware intensive, and like even if you wanted to start like the smallest thing, you will need hundreds of thousands, probably not hundreds of thousands, but you will need a lot of money for that. But at the same time, no, I totally disagree that robotics engineers are paid not enough. We are paid fine. And about the job markets for robotics in Europe and US, of course, is everything tech related, a lot of opportunities. But I would not want to live there. I'm happier with Europe, and in Europe there are countries that you would want to consider if you were to be interested in it. Germany, Estonia, Netherlands. These are the ones I hear about the most about the field. But of course, almost every country in Europe you would be able to find something. But for example, if you are interested in a job in Estonia, like I know 3 companies right now looking for engineers, and they are offering decent salaries.
Thank you, thank you. As I see that in our chart, there is competition. Rufat is writing, then Rulana is writing. If you want, open your microphone and ask directly. Okay, let me read the question. Rulana is asking again that if you are dealing with that, how do you stay technology
agnostic?
Yes, when helping someone pick between robot designs and that are so different.
Yeah, well, robot designs, you might think that they are different, but at the end of the day, they are getting optimized and getting into the same shape. Basically, the robots for the same purpose will turn to look the same. It will be in case of, and because for every application, there is a like, let's say an ideal form factors that you would want to have for that task, and you would want to go for that one. So it is, yeah, it depends on the application.
Okay. Rufat again asking, what part of software stack are you working on? Reception planning or perception planning and decision?
Basically, I work on perception and planning, depending on the time. Basically, I work in startups, so you have to wear a lot of hats. Like I was doing DevOps the other day, so it's not like I deal with only one side. But I love working with planning and also perception because, well, my current thesis is about perception, and this planning is how I started, because planning is rather easier to understand the mission of it. Planning is basically, this is a point A, this is a point B, just find the best way to get there. And that's how I started. I started with planning.
Okay, next question. If all autonomous driving companies use same or at least similar algorithms, what makes them different from each other?
Good question. Well, the thing is, when we talk about ROS and Altiver, it still doesn't give you the full technology stack that you would be able to use it for everything. You would have to do your own development anyways. And these companies have different business models. Let's say that, I don't know, Tesla is trying to have personal vehicles that are that you can, let's say, that will drive its passenger, drive its owner. Amazon Zoox is trying to have a passenger carrying buses that will be, that will have an app. It will be like Uber, you will call it. And Uber itself was also working on this, but they couldn't make it profitable. And they left the autonomous driving scene. I think that Bolt is working on that right now. But yeah, their business model is different, and based on your business model, you will need different features, and based on that, your software will be different. And these middlewares, although they give you a lot of ease of mind, they are not really the full system. So in the end, if you didn't steal your code, it will be really different than others.
By the way, I would like to mention that we will share the presentation, the video, and you may find from GitHub repo, from Slack, and all information we'll share after meeting. Yes, Nisa Hussein is asking that. She has two questions. What's the security level does have autonomous driving systems? It's the first question. And the second question, I mean, the developing such as V2EX system would be some concerns related hacking of the systems.
Mm-hmm. Yeah, hacking is a real consideration to have. Basically, this V2X or not, it doesn't really matter if someone is trying to access your system, and in our case, we are trying to limit our ports and access to internet, and using some regular security considerations. Basically, it depends on the size of your startup also. For example, we haven't, some startups might be small enough to not have a security expert on board, and I am definitely not the one to deal with this cybersecurity issue, but it definitely is possible to have a secure system. Of course, not totally secure. There will be hacks happening. It happens with the biggest companies, the best security engineers in the world. Still, that kind of things happen, but there can be things done to try and limit it. And as we face it, it's basically a game of cat and mouse. You find some vulnerability, you fix it, or you try to hire the best people. But overall, I'm not sure I can answer that question in more detail, because I've not dealt with security part of this.
Okay, as I see, the students are very active now. They are asking, what are the robotics related top open source projects, conferences, and events you recommend?
Okay, yeah, well, ROS, our bread and butter that we were talking about, Outware, also open source. The tools that I was showing for visualization, web-based, also open source. It's a good tool to have. About conferences, well, there is the ROSCON happening every year. This year, I guess, not going to happen, but that's one of my plans to try to attend that in some of the next ones. And there are other like more local events also. If you are closer to Estonia or have the ability to come here, we have this event called Robotics every year, where students from different countries and different universities create football playing robots, basketball playing robots, line following robots, all kinds of robots that that are fun to work with and is a challenge that is needed to be solved. So yeah, and events.
Next question, again from Nirvana. Nirvana is asking that what are the common technical issues rising while creating the robots from time to time?
Common technical issues. Well, let me think about some common technical issues. Oh yeah, there are sometimes problems with internet connection if you are, let's say, if your robot or your vehicle is in some location that you cannot access, but you are trying to access it over internet. There are many electronics and mechanical issues that I sometimes don't even know how to fix, because those things might be normal and common things for other engineers to fix, but if you don't have much of a knowledge in that, that can happen. The thing with interesting thing with autonomous driving vehicles and some common issues there is that you cannot use the same components that you would use otherwise. What I mean by that is that, for example, you would need to have a computer. You would need to have some computer like you have at home with a good CPU and GPU, and your home computer can run the software, let's say, that you are trying to run on this vehicle. But you cannot put the same PC there, because inside of the bus, there will be a lot of vibrations, a lot of like going up and down, and you need to have a different kind of an architecture, not architecture, different kind of a box for it that will negate the vibrations or the speed, and you would need to protect it from rusting, etc. And those kinds of things take consideration and make things a bit more expensive. But yeah.
Okay, next question. Could you advise if current autonomous car manage to drive in general gravel village roads, or it's still definitely need roads, signs, lines in place to drive?
Yeah, it is. It's an interesting question. It depends on what. It depends on context. As in, like, I know that there are some, let's say, companies that are dealing with off-road autonomous action. Let's say military companies, for example, or some companies that are working in agriculture. And let's say if you are in a farm, you won't see a road at all times, and they are working on it, but it's not that feature hasn't come to the autonomous cars that you and I can drive today. Those are meant for more specific use cases. So I wouldn't expect the gravel village roads to be passable today, but probably in the future it will become more of a thing.
Thank you, Elmar. Any other questions? Okay, if we don't have question, let me ask one thing. Elmar, engineering is that testing, fault, again, testing, fault. Could you please share your experience? What kind of the fault accident you faced while you are doing in your job? I mean, it's not detailed by facts, but just overall, what happened and how you survived in that situations?
Oh yes, it's definitely important to have safety measures if you're working with autonomous vehicles, because I remember this case when I actually didn't turn on the sensor for actually seeing where the car needs to go, but I actually turned on the algorithms that would, make it try to reach its place. And the issue there was that I didn't put any safety code to check that if the sensors are working, then like do this, try to reach that place. And Well, basically how it happened was that the car started just driving crazily around me, and I had to actually find the big red button and press it to kills the communication, kills the engine. That's an important part. Basically, if you ask me like what every autonomous car has to have, it would be a one big red button that you can just press and it will stop. And that's a necessity for when you want to avoid failures.
Elmar, the Elvin is asking that, Elvin is asking that, do you have any experience or heard about any news improvement about the wireless charging of cars?
Wireless charging of cars is probably not going to happen soon because there is a wattage and that's needed. There would be crazy big amount. Maybe it will be possible sometime, but I haven't looked into it. But at the same time, there is a simpler way that I know that companies like Tesla are working on right now. And the simpler way is to just, when you come to this charging station, just take the whole car's battery out, empty battery out, and put a charged one instead. And what I like about that solution is that it is a kind of a simpler mechanical solution that will work even better than, let's say, the best wireless charging you can have. I mean, if you want to try with wireless charging, I don't think like even phones charge that fast with wireless charging, let alone a car. It will be kind of way more difficult to achieve. But I like that idea of just changing the whole battery of the car in a few seconds.
By the way, I'd like to mention that Elmar's father has the robotics museum in Baku in Azerbaijan, and I shared the link. You may click the link to find the amazing, to look the amazing the environment which the Elchin Abbasov is made. So let's turn to another questions. If the audience doesn't have question, let me ask some question from my side. You know, Elmar, sometimes we have the people, all car accident is coming from the human, yeah, human.
Mm-hmm.
But we have the non-standard issues like traffic jams, events, traffic jams. How its impact to reduce traffic jams, the autonomous cars, if reduce or not, I mean, how impact, how is the perspective of in the future to develop the robotics and autonomous car will impact to reduce of the traffic jam. You know, traffic jam problems in the world, in the big cities, in the megapolises, and etc. But question is that in traffic jam situations and non-standard events, how they survive and how they feel your autonomous car?
Yeah, that one comes down to like there are different solutions that people are trying to implement in order to work with that. One solution is to have like my current company is doing, it is to have more of a public transport kind of thing, so that you're let's say that you will have an app that you'll be able to call a car, or it will be going through some standard route, and it will be, you know, basically we are talking about these self-driving cars and etc. But at the same time, it doesn't really reduce the congestion or like how carbon emissions of the cars. It doesn't do much about that. I mean, of course, there is, if you're using electric cars, it's a bit better. But at the end of the day, it will take quite a while. And basically, if you have, let's say, 80% of the roads, 80% of the cars on the road that are autonomous and are going at correct speeds and doing that, and it has this like V2X that we talked about, that the vehicle will be connected to the infrastructure around it. In those cases, yeah, it can be, you can have algorithms in place that will make sure that the cars go at optimal speeds to reach their destination in time, and there wouldn't be any accidents or congestions. But currently, I wouldn't say that that's something that will happen before at least like half of the vehicles on the road are autonomous on some level. But it's an interesting thing to think about.
Okay, Elmar, when decision making with your autonomous car is decision making, that thank you, Sako, for your kindly the sentences that the cars, when collected information from sensors, cameras, and different sites, they have the lots of the sets, and how the selection from that information the car is used. I mean, which kind of the selection algorithms is useful for kind of decision making?
That's one of the important parts of it. It's about being able to decide what to use. There are different ways people are dealing with that in that sense. Are you asking about this decision part, or or overall like decision making process? Which one are you asking about? Are you asking this decision block, how algorithms are chosen here?
Yeah.
In that case, you should just like in this picture, you should try to not have your decision coming directly from the sensor data, because if you make your decisions based on some single source of sensing, it's not going to be very accurate. For example, yeah, as I mentioned, if let's say the roads it's nighttime or it is raining or something, you might wanna use some other sensors more than other ones. So what you do is that you make sure that your perception is better suited for taking different kinds of sensors and making better, and basically giving better information to your decision making. And your detection and prediction should be good enough to determine by themselves which sensors and in which combination to use. But it is a difficult process, and that's like a lot of cutting edge companies are still working on that problem. So it's a good question.
Okay. Do you have any question? Okay, if you don't have question, let's ask one more. Okay, question related to the startups. Elmar, for instance, some people, students or some software engineers decided to start startup related to robotics. Yeah. How they should start? I mean, what should be the level of that someone who will start in robotics startups in the future? It can be starting from the zero, or it can be joined to team some the expert like you, for instance, or etc.
Yeah, it depends on the scale of the startup mostly, like, because you can have some robotics startups that's I know some small robot that's good at like just one task, which will be something similar to a toy than a like actual robot. But and I haven't really had an experience with entrepreneurship in that sense to start a robotics company. But overall, it's basically, you have to think well before doing that, because it's quite a capital intensive field. If you want to have robots, if you want to build and sell robots, you need to have factories working for you, and you need to do a lot of trials and errors. Just that football playing robot that I showed like in the beginning of this, even that cost close to €1,000 in just total price of the components. So it can be difficult, but to start, I guess like the first thing is the same with every other startup. Make sure that you know your target audience and you know that your target audience actually wants your product, because otherwise it will not work out. And then later the technology and how to do it is kind of the secondary. You need to know the audience and you need to raise some money.
Okay.
But at the same time, yeah, I'm not an expert.
Okay, Elmar, the project is at Co-op 0 to Hero. Now you are our hero. That's why the IPARA is asking that, having studied robotechnics, you are robotechnics, studying robotechnics. How the student studied robototechnic? How did you decide to move this as a field of robotics? I mean, it's an interesting question, that how you decided to move to exactly the robotics engineering field.
Wait, I'm not sure I understood the question correctly. Is IPRA studying radiotechnics, or she thinks I studied radiotechnics?
Yeah, she asking you, have you studied robototechnics. How did you decide to move the field or robotics?
Well, my field was
Maybe
information.
you may give suggestion for students.
Well, for me, it was mainly about, I just tried different fields of software engineering. I did game development for a while. I did web development for a while, and I did some hardware programming. And I noticed that that's the one that gives me my most enjoyment, and that probably should be how you base your decision. Give it a try. Do some projects. If you like what's happening, I was crazy happy when I wrote some program and like I could actually hold the thing that I programmed in my hand and it was behaving in some way, because software engineering can be quite an abstract thing most of the time. You write code, you see something on the screens, but in this scenario, you are dealing with something that you can hold in your hand or you can get into and drive somewhere, and that was exciting for me. And if that idea is exciting for you, also give it a try, see if you enjoy it.
Great, thank you. Another question? Okay. Let me check.
I think thanks so much. First of all, Elmar, looks like we are coming to the end. I just wanna, actually it's not my field, but just I would like to, in general, to get better understanding. Like, if, for example, as people for starting, do they need, like, for training and so on, bigger compute resources on that field, or it's fine with their laptop and they can do some small testing and so on, and buying some tooling, so on?
Yeah, good question. For me, when I started, I started by playing around with Arduinos and Raspberry Pis, which are like, I know, $10, $20, $30 PCs that you usually attach to another PC, and that other PC doesn't have to be like that greatly powered either. It comes down to what do you want to achieve, because, for example, if you want to run a real world kind of a simulation to test your autonomous car setup software, then it will require a decent GPU, like graphics card, and decent processor to handle that. But if you are, let's say, just programming simple hardware, then you might not need that. And with laptops, I have been using laptops for the last 2 or 3 years for development. I mean, it is a good laptop with good graphics card and CPU, but at the end it is a laptop. So you don't need to, you don't have to go very expensive if all you want to do is to actually do the development for, let's say, ROS or Arduinos or Raspberry Pis. But yes, there are some parts of it which require higher budget computers.
Okay. And one more question. If you look at the market, which markets you think like at this point heavily invest for autonomous driving, the countries are, and what are the top, some of the companies using that most of the industry top engineers want to go and work for?
Well, definitely Tesla is one. Definitely Amazon Zoox is one. Those are based on basically hype around the companies. There are other companies. There are many other companies, small companies, trying to solve some smaller problems. Some companies try to be, let's say, the autonomous bus for public use in some cities, and some companies do go for some other business decisions. But overall, the most funding, I would say, definitely, of course, goes to US and Silicon Valley, and China is a big player in this also. China, some Chinese companies are doing some really impressive feats in this field. And surprisingly, Netherlands, I'm not sure why, but Netherlands also has a flourishing industry. And I would like to mention Estonia also, because like in concrete, even if in concrete terms not big, it's big for its size. The country is like has 1 million citizens, and there are like 5 companies dealing with this. So it's like according to scale, it is a big industry, but of course, overall, in the grand scheme of things, not so much.
Good to know. Thank you.
Guys, any other question? No, maybe questions session.
I think we are good with timing. I think, yeah, that's, I think, amazing job, Elmar. It was really great
Thank you.
session. It was like first time in robotics and GOP, 2 years history. That's great. Hopefully we can see more, because we were heavily on software side, but because we didn't have any actually many in our circles people with robotics, so that was great. Good start. So hopefully we'll have more engineers coming out. So.
Hope so.
I would like to say that as I know, before starting our webinars, we are analyzing the speakers. I saw that you are master in Estonia, but you will finish your thesis. I mean, I heard from your side, you have taught as an instructor in your at your university. Yeah, it means kind of the professional. I mean, the specialists like you can be mentor for at universities or for our community. But how the students, how the person who will in the first stage, I mean the associate stage, how to find a mentor like you? What your suggestion? What is your suggestion for them?
Well, it is difficult to say, as in because you would probably want to find someone who is, close to you, who is in your own country. That would be better, because if you are, working with hardware, you actually need someone to be there to plug things in or show you what to use and stuff. But other than that, I am sure that universities there are people dealing with that. And I mean, even outside of the universities, I've seen some recent projects where engineers meet and do some networking that you can look into. I would have to check back on what kinds of events they were, but I can definitely provide some more info on that. But overall, I would suggest that it's not a field where you would definitely need a mentor. You would need teammates to do projects with, because for me at least, I would be in most of the projects that I was involved in, I would be writing the software, but there would still be needed people who would deal with electronics part and mechanics part. And the best way for me to find people would be going to these hackathon events or robotics competitions and events like that, where you will find people and do that. And if you are joining a company, you would probably start with an internship position or a junior position, and you will definitely get to learn from more senior members. And that's how I started 4 years ago. That I started as an intern in a robotics company, and then I got a job offer, and then I got into another company. That's how it started, and that's, I believe, a normal, good progression. But of course, your mileage may vary.
Thank you, Elmar. I have decided. I also found my mentor. You will. I will ask you in the future. Then let's finalize with one question. Our today's session. The Aypara is asking. Maybe she saw the one slide where you have represented to us AI and robotics. She asking that what's the difference between robotics and artificial intelligence? Is robotics part of AI, or is AI part of robotics? Good question. Thank you for Aypara.
Good question. Those two are separate things, as in one can exist without the other. You can have artificial intelligence that is not a part of a robot, and you can have a robot that doesn't have much of an artificial intelligence. I mean, that also still comes down to what you consider artificial intelligence. If you consider if else conditions artificial intelligence, then yeah, robots do always have some artificial intelligence. But overall, basically, yeah, I guess you could answer it so that robots will most likely have artificial intelligence, but artificial intelligence doesn't have to have a robot to be useful.
Okay, maybe for first attending to the community for Elmar is enough. you have the share more information with us, and it's really valuable for our community. I mean, our community, whenever we'll watch these records, and they will move to your side to asking different questions, I'm sure. So if you don't have question, we can finalize the meeting. Please turn to next slide, Elmar. And if you want to contact with Elmar, you may find his Elmar from this link and the LinkedIn. And next slide. If you want to join our community, you may we have the open issues in GoUp GitHub repo, and welcome to. We are waiting your attitude in our community. Our community open for all who want to contribute with us. Thank you. Next one. Thank you, Elmar. Really appreciate today's speech and today attendance to the webinar. You gave some value to the community, because it's a very actual topic and a very trend topic, and you know the field is more general. I mean, a lot of information they need to learn to be experts, to be the professional like you, and find a job in the abroad and etc. Thank you, Sako. If you have some question
I just want to shout out and thank you again, Elmar, and thank
It's
you all
pleasure.
event like Rasim, I think, Humay, Paran, Lana, Ravi, they're really doing amazing job. It's really appreciate, and obviously our friend, one of the biggest supporter of Vurgun Hajia as well. Thank you guys, and wish you a nice weekend. We're gonna have another session for Cloud Journey, which is gonna be in literally in less than 12 hours. So hopefully, if you're still around, feel free to join. Thank you guys.
Take care.
See you. Thank you.
Thank you.
Thank you.